On our last problem, I spoke about the power of compound interest and how it's a product of the number of compounds that happen, as well as the interest and the time. The question was once asked, what happens if you just keep compounding? We can compound daily. Could we compound hourly? Sure. Could we compound minutely? Of course. Could we compound secondly, as in every second? Yes. How about every microsecond? How about just continuously compounding? And that's where this comes into play. Continuously compounding is going to take advantage of the letter E, which is a value. I can see it on screen here. It's kind of an easy mnemonic device that I found to express E. Remember to memorize a sentence to simplify this, as in 2.718281828459045. Kind of fun there. You don't have to know the value of E, however, to do compound interest. Your calculator already has E, much like it has pi, built into it. Now, the method we're going to talk about is called the shampoo method. The PERT shampoo, P-E-R-T, you're going to be a part of it. That's why I've included the shampoo bottle here, because a lot of people like to refer to this as the shampoo equation. And by a lot of people, I mean mostly me, I guess. All right, let's clear these images off and talk about the equation. The equation is A equals P times E to the R T. As you can see, the PERT. That's why the PERT shampoo was on the last screen there. All right, so A is the same A we knew from example 2, as in it's the future value. P is still the same P. It's the principal. It's the starting value. E is now E. It's this value that is 2.71828. Represents a natural number that was found that deals with compound interest in anything that grows continuously over time. R is still the interest rate as a decimal, and T is still time in years. So there's not much difference between the shampoo equation and the compound interest equation that we saw back in example 2. The main thing is we don't have a 1 in this thing, and we don't worry about the compounds because E takes care of the compounding. But this is for things only that are compounding continuously. If they're not compounded continuously, and there's a number of times, if there's a finite number of times, we want to use the other equation. But compounded continuously means infinite number of compounds. So let's look at example 3 on page 380. It says, what is the future value of $26.50 invested at 8 years at 12% compounded continuously? And then it also asks how much interest this will earn. But what do we know about this? Well, the A is what we're trying to find. The P that they gave us, the principal, the starting value this time was $26.50. The R, the interest rate, was 12%. We're going to call that 0.12 for us. And the time involved was 8 years. All right, so we've got the principles. Let's set it up. A is equal to $26.50 times E to the power of 0.12 times 8. And that's it. So we bring our calculator up, and it's going to do the brunt work for us to tell us what it equals. We already know that A is going to equal something, and it's going to be in dollars. So let's go ahead and get that down first. And now we can bring our calculator up to get the answer. All right, so I'm going to start this one with E. So I'm going to start with second and ln, and it says E to what power do you want? And I say 0.12 times 8. I get that answer, and then I can say times $26.50. And in this case, $6,920, $6,921, since our change on our decimal here as the 5 affects the 9, which then affects the other 9, which says $6,921. So how much in interest is that? That's part B of this question. Well, it's $6,921 minus $26.50. So let's go back to our calculator. It's already on here. Let's just say minus $26.50. And it looks to be $4,271 is the interest. Remember that the A value, whether it's in this equation or the last equation, always includes the amount we put into it plus any interest gained. And so in this case, the interest is $42.71 because we put in $26.50 and the grand total was $6,921. Now, 8 years isn't a very long period, but 12% is an exceedingly high amount of interest that you would get. So I don't think you can find 12% in today's world very often, if not at all.